So good afternoon, all present in this session. So I welcome you all to this ninth session of this FDP. And today this session resource person is Dr. Gunajit Kalita. Already, so we are familiar with Dr. Kalita. So now I request Dr. Kalita to say deliver the lecture.
Thank you, Manas sir.
Yeah, thank you, sir.
Today we'll discuss about mm, different quantum tools available till date, as much possible, not all. Just a brief discussion about that. And if time permits, then we try to discuss few um, language or simulator. Particularly one language we'll discuss. Eventually, that may help to study some sort of quantum language or quantum simulator. So maybe it will be a little bit boring in the beginning because it will be totally just sharing information. And those who are interested in programming maybe get some interest when we discuss the other part. So try to bear with me. First of all, I think you have got some idea about at least something about those who are new to this. What is quantum computer? The representation of the states or bits, it is your qubit, and other aspects of the quantum computing. At least the brief idea you got. So today I want to show you what are the things available in the world regarding different quantum computing tools regarding quantum computing. So let's start. So lots of companies are involved in designing, not only companies, some universities are also there. They are involved in designing their quantum computer uh, and related tools for that. Uh, but what I think the main issue in quantum computer is, though there are two quantum computers available in real sense, I think still they are having a few issues because there is normally the quantum system perform in the atomic level, and when it performs atomic level, it is very hard to uh, control the electrons or internal structure of the atom. It's very hard to, control them. So once that accurate technology invented, maybe then thing will be much more accurate and better. That's why at this moment, once we see the quantum computer, they are come with some sort of error or some error probability will be always there. In fact, while computing in many simulator you'll find people used to inject error so that we can estimate that much error is tolerable for us. But simple computation, this error is not an issue. We can handle it or we can just avoid that, ignore it. But for some very accurate kind of thing, realistic, where realistic information are important, then maybe they are not, they may not perform as you expect. But that is not limitation of quantum computer. Limitation is we are not at par. Quantum computer is quite capable, but once we can handle all these internal things, maybe someday we'll make it far better. Anyway, let us see. So first, Microsoft, we all know Microsoft. They started with one um, software tool or a suite kind of thing. It is known as LIQQI. They started with this. So you can, it's a free tool, you can use it. All right, this basically implements some quantum algorithm. You can simulate them, you can optimize them. All right, so it's a kind of tool package, you can say. So this LIQA basically stands for Language Integrated Quantum Operation, and it can be used to translate quantum algorithm written in the form of a high-level program into a low-level machine instruction for a quantum device. But though it is mentioned here for a quantum device, but ultimately that low-level concept of quantum device, again, we are not very much happy with the kind of things available, because we understand to run a machine, if it is a digital machine, we require an set of instruction or instruction set, that is how the internal thing will work, all the machine code and machine kind of internal kind of thing. But for quantum, the very definite kind of instruction set not available. Whatever is available there, they always refer to the classical one. Classical means the conventional things we are doing with our computer. So they always refer to that. Meaning is when they try to see it, they always measure it or refer to classical computer. So that is still there. So I hope someday everything will be done over quantum only. There won't be any reference to
Sorry for interrupting you, sir.
Yes, yes.
Sorry for interrupting you.
Yes, yes.
It will be better if you make your presentation in full screen.
Yeah, my problem is sometimes what happens if I make full screen, it what I see here, it never, I mean, skip or never change. So that is one. I'll try again.
Okay,
That
sir.
day I tried, but it was not possible. Let me try. Maybe today it will
Okay,
make
sir.
that. So this is one tool from Microsoft. Next is changing. I think it's changing again. Can you see the second slide? This is the problem with this.
Yes, second slide.
No, it is Microsoft QDK. Can you see that? Microsoft QDK?
Yes, sir.
Okay, it's coming. Okay, if it's coming, it's fine. If you get some problem, you just inform me so that I can again make it right. So next tool is again from Microsoft. It's Quantum Development Kit. It is basically based on LIQI. So newly named quantum programming language is there, which is the name as Q Sharp. Like they have C Sharp. C Sharp is a visual Visual Studio kind of thing, like your Visual Basic, Visual C++, and C Sharp. These are part of that. So looking into that, referring to that, they design one similar kind of thing called Q Sharp. But to work with this, you require that Visual Studio again. Only because lots of libraries are there, which the Visual Studio library also applicable in C Sharp. They use them. That's why you have to install that under Visual Studio. Then only it will work. So it's, it's there. A simulator can be run either a local system, or you can use Azure platform of Microsoft, right? So for that you need to create your account, and certain extent they are free, but if it is a little bit big or more, then of course you need to rent it or you need to pay for that. So it's having lots of libraries, and some code samples are available, so you can design circuits. Some examples also given in that. If you sharp, you can install, very easy to do so. And next one is very familiar, very popular in today's world, and most of the people are using this and also contributing to this. So IBM already has designed one quantum computer that we know. It's a 5-qubit gate level quantum processor. And to work with this, they actually connected that system with a web application, IBM Q, that is here, IBM Quantum Experience, you can say, that is. So here also you need to, create your own account, and they will give you an ID. Using that ID, you will get some time to use their hardware. But normally from the world, they are taking requests to process different programs. So maybe you will wait for some time. You'll be in a queue. Once job is done, first come first basis, then your job will also be done. So this is a very good one, and many people are using this. And here you get some instruction as well in the form of tutorials. And there is mainly the 4 modules here. One is your tutorial about how to work with like that, and one is your quantum composer that will allow you to configure the gates and circuit for the qubit. There's lots of symbols right there. Perhaps some
Sir,
of
the slides are not changing.
moving now. Yeah. Then
The
that
slides
was
are
the
not
problem.
changing.
Anyway, yes. That was the issue. I know. Can you see this now? Can you see IBM?
No, sir, I
Yes.
can see. The slides are not changing.
Yes, sir.
No,
The slide
sir.
IBM is
Okay, let me again see this. Can you see that Microsoft SDK, QDK? মানে
Yes, sir. Third slide is on the screen. Microsoft QDK.
okay, next it is changing to IBM.
IBM, yes,
Is
no.
it?
Fourth slide.
Okay,
Yes,
okay.
fourth slide.
If I make full screen, some problem is there. I don't know what is the problem.
Okay.
Anyway, I'm sorry for that. So next is IBM. IBM having its own computer, quantum computer, real.
Sir, it is
hardware.
now visible. IBM is visible.
Okay,
Sir,
fine.
IBM is visible.
Okay, fine.
Okay, sir. Thank you, sir.
Now IBM having its quantum experience website where you can create your own account, and you will get one passcode for that, and using that you can use their hardware. And before that you can simulate your program quantum description or the configuration in your own computer. So if you see this in your own computer, maybe your result will be a little bit better. And when you transport this to quantum hardware of IBM, and then you get that result, there is a little bit issue. Again, I told you, because internal structure of atomic structure is very difficult to handle, and so noise will normally introduce. So we have to right now we have to bear with this. Maybe in future we'll get a very accurate kind of computation. Anyway, so in IBM Quantum Experience, you'll get 4 modules. Here, one will be a tutorial from which you can study how to work with that. Some examples also given. Next is a quantum composer. There will be lots of possible gates and other things are there. You can use them. And a simulator to run these things. And this is basically the program here, right? Normally in the form of Python syntax. They are basically the Python kind of things. Python is very light, maybe that's why they use that, and lots of external contribution also possible, and no, hard type of things. That's why it is very easy to maneuver. That is the reason they are using Python for that. And at the end, what we do, you need to access the actual hardware, quantum hardware that is there in IBM head office. So from again, after simulation, you need to transport them, and for that you need to connect first. Writing one, maybe tomorrow we'll discuss about that. I'll connect that. Once you make a connection, then you can run, and maybe you need to wait. I told you, you need to wait for some moment, because there are lots of people working with this. Anyway, next one is your, this is also very important, Regated Forest and Cloud Computing Service. Regated Forest is a company, and they have a cloud computing services, QCS. So they have a quantum instruction language name is QUIL, QUIL. Open source Python library basically. So these are known as PyQuil, right? So quantum programs like Groove and simulation environment, it's a virtual machine kind of thing, CVM is there. And these visuals available in GitHub also, you can see, and you can, if you are interested, you can do and try. Lots of actually things right there. Some are program specific, problem specific also. So then, depending on your domain, you can go for that. Anyway, it provides a virtual classical computing environment basically. It's like your quantum experience sort of thing. And Rigetti also having their own quantum hardware, and you can work with that. They're giving a software kit for that, development kit for that, right? So in your front end, normally you will work with your SDK, and back end, the processor will be there. Again, in between, I want to tell you, when people are talking about qubit, you know, when qubit is, suppose you are working with a computer of 6 qubit. So suppose amount of memory required for that particular, to handle those qubit is, say, just I say X. Now I change 2 more qubit or 1 more qubit. Then your requirement of that memory will be very high. So it is very difficult. If your qubit is very large, you want to compute or configure some circuit of higher qubit, then the computer at present we are working with is not capable to simulate them, because we require lots of memory, big memory. So that's why if somehow someday someone will develop a real quantum memory or some other form of memory to handle this, maybe that bigger qubit processor possible. At this moment, they are not sufficient. Means we at least cannot simulate classical things with that. So that is we need to understand. And next one is CS, or CAS, we can say Alibaba Quantum Computing Laboratory, superconducting quantum computer. So this is 12 qubit superconducting conducting quantum computing. Okay, many things are not available. So though they are claiming it is 12 qubit, we don't know whether it is really 12 qubit or less. But anyway, it is Chinese thing. So sometimes we need to carefully look into that. This is particularly optical quantum computer, because they are also working lots in this field. They also teleported signal from the ground station to satellites, they claim. So using this quantum teleportation technique, so, they claim that. Anyway, so it's a larger superconducting quantum computer they are trying to develop, and it will come soon. Anyway, so their hardware system are available. So again, like an web portal, we can like to design a quantum circuit and then remotely execute. That is new norm, right? And you can save them, and you can see they are, saved in your cloud system. Anyway, the website normally supports running circuits on both quantum computer as well as the simulator. Simulator basically we say classical computer. The platform have 5,000 registered users. They say you can also join if you want. Another one is Project Q. This is an open source software framework for quantum computing. So this is also implemented using Python. It allows user to write their quantum program. So quantum program, we understand this is basically concept of quantum gates. Tomorrow we'll see that. So there are some very good sort of command to utilize them, write them. So that is there. Project Q can again translate this program to any type of backend. Any type of backend means if Rigetti allow you to use their hardware, you can use them. If IBM allow, you can use them, no problem. So that flexibility is there in Project Q. So till date, those are, I mean, they're supporting all this. Some are not supporting. Maybe they will make it happen someday. Another is your StackU. StackU, we'll see little bit about StackU later. StackU basically Google unofficial, but it's from Google, right? Google has not made this as a product of their, I mean, whatever set of product they have, like Google, YouTube, like that. So they are not claiming this is their product, but it is in Google. If you go for documentation, you'll see that. So it is a product of Google. So StackU is open source, again, is Python based. So you can write your own quantum program. And normally here this concept is used, noisy intermediate scale quantum. Noisy meaning that error we are hearing about. So that error is introduced here so that you can at least look into the probability of what will be the error, what may be the error, or try to minimize that. You can investigate that thing. That is. So it is currently in alpha release state. Maybe once it has become sound, then it will be part of Google, officially Google. Unofficially it is Google. So also, and can also use it open fermion. Fermion is again open fermion is another thing. So it was initially developed for not SIRQ, open fermion we are telling, is for chemistry problem. So people who want to work with chemistry sort of thing, then directly they may not choose other language. You can directly go for open fermion. That is also there. So several software companies also working with StackU because it's a Google thing. That's why people are more interested and try to adopt it. Anyway, and next is again StackU Project Q. It is basically a port between Project Q and StackU. So main things of both the Project Q and StackU are actually combined in this StackU project. So like that. Next, another is Pennylen and Strawberry Fields. Like Xanadu is another I mean, organization where this Pennylen and Strawberry Fields. This is one name a little bit weird, but it's there. So it's two different software products for programming quantum computers given here. The first one is your Pennylen. It's a crossbred from basically again Python for machine learning purpose. Normally it is there. So here you can, I mean, optimization things are there when you go for the simulation. Simulation will come means there will be classical thing. So classical competition and next is your shell hardware quantum program. So that hybrid is also available here. So this again Pennylen also support that IBM and Project. Right? And it's your own another product. Second product is Strawberry Fields, Pennylen and Strawberry. So it's a stack Python, full stack of Python library for simulation, design, optimization, like that, and changing quantum optical circuit, particularly quantum optical circuit, right? And they are trying to develop one hardware product. They are with a hardware, but that is not a big one. Better hardware. That's why you can, if you use Pennylen and Strawberry, so you can use IBM backend, that is known as AER. IBM backend is known as AER. I think they have three backends. One is AER. Another is when you write program, you will see that. One is open control from QCT realism content. So from there, it is again all Python based. Most of them are Python based. Some are C, C++ based, but this is Python based. Easy to create and apply. And establish error robust quantum control protocol. So from here some machine intelligence is also involved here, because if, lots of available literatures are there, people are working on this quantum. From that they can extract them. Machine intelligence is involved here. So like this, and it is easy to confirm if things are there. You can, if you want, you can install and work with that. Next, Intel. Intel is we understand for classical computer. Intel is a very prominent company, so they are also working with that. So they have a simulator, because initially named as Q star. Basically, it's a single node or distributed high performance implementation of the quantum simulator. Right? They are actually working with quantum computer, but problem is they are not declaring it yet. But Intel is working on quantum computer, because quantum computer, as officially declared by Google, IBM, some universities like MIT and so, but Intel is not declaring officially, but they are working with computer. But they have already simulation software and packages. One is your Q style. So this can generate single qubit or 2 qubit control bits can be handled with them. There, yeah, algorithm not an issue, but real hardware case is an issue. And so they are targeting to make it better in fact. And next one is Mythic. Is again open source. You can easily download, no problem. With the intermediate scale quantum computer, it is good. Normally working with that. United, it is developed by one United Found, and it is compatible, so you can use finally the backend of IBM or StackU or Regated backend. That is your, which is hardware you can use. So Mythic doesn't have any its own quantum computer. That's right. So you can use that. It will do the conversion to OpenQSM research. Okay, OpenQSM is quantum assembler basically, QSM. So OpenQSM means anyone can develop and join and do that. Right? So basically the circuit, they can mitigate the circuit by running it on noisy simulator or any real device. Noisy simulator, again I am telling you, it is an introduction of error. Real device means normally we expect the actual quantum hardware. So again, since it is a simulator, no hardware, Mythic, with Mythic it is possible to implement zero noise extrapolation technique. Zero noise is possible, but again, using Mythic you can do this simulator because it will perform this in the classical system. But again, if you connect with your IBM backend, suppose, or maybe Regated backend, again error will be there. So it is only for up to unless and until they develop their own quantum computer, it is difficult to claim that. They are claiming because classically it's happening. It's a software it happens. Another is by Berkeley. It is BQS kit, Berkeley Quantum Synthesis Toolkit. So it is basically for optimizing quantum comparison. Again, people are working on this. Lots of ideas, different projects from the Berkeley National Laboratory they are working. So its main aim is for providing optimized compilation. Basically, they are trying to make it better. And one is already using an advanced QuIST, so they are trying to make it better. So they are one forerunner in this field. Software basically, not hardware again. Another is Q circuits. So again, it's a quantum circuit simulator for even Python this. Right? So it will be easier for students if students are interested to work with. So it will be easier for them. Because this is designed looking into the students only, or researcher also. So looking into that. So Q circuit is good for them. So it can simulate and again operate on small level quantum computers. Right? So we need to be careful because if we design big, it will not crash it. So anyway, so yeah, it is a type D0 and type D tensor to represent the state vector. Because we know qubits are represented in state vector. All right. So does the D qubit system can be simulated? The problem is when you go for a hybrid again, you have to be with the primitive, right? Small scale quantum computer again. Anyway, so some mathematical things can be done. So another is Yao. So this is also most of the people are telling a language, but many of they are using Python. So I think in that sense that is not language, it will be FAQs or a development kit, you can say. Because to be language, it must be independent. Right? So once you take help of other language directly using libraries standard library from that language, so then you just can't claim it is a language. Anyway, here is one open source framework for quantum algorithm design. All right. So they are claiming it's state of the art performance in simulating small to intermediate phase quantum circuits, right? And trying for better one, that is they are claiming it is written in a Julia language. Julia is a different language, so written in the Julia language. Another is a StackU. So new high-level quantum language developed by, it's again designed by the University Zurich, PTH Zurich. That is an university, perhaps you know, a very good university. They have designed this. Basically, it provides language that can enable the code that shorter, simpler, less error prone. They're trying to make it in that way. And what they are telling that the number of line will be less than if you compare with Q sharp or Q number of lines will be less. They are trying to make it a little bit concise. And claiming that way. Another is pedal quantum. So pedal quantum again from China it is. China is working hard in quantum. So quantum machine learning this thing. So they have their own search engine Baidu, right? So that Baidu flying pedal, basically like Google doing their quantum, so Baidu also doing their quantum like that. So it support construction and training quantum neural network because machine learning related. There is a key for optimization, chemistry, and other applications. Next is Tequila, is an essential quantum information and linear architecture again. So the main aim is to again to make your quantum algorithm or new quantum algorithm existing, not only existing like source algorithm or so on. Not only that, the new algorithms on design, they want to make it faster and better like that optimized. So it operates on abstract data structure, allowing to formulation combination of its own syntax. They are telling about own syntax. And there is QLEX. It is a Python, also C++ based kit. It is designed by Japan, Kyoto University. And designed, developed by Kyoto, but it is now maintained by a company. Actually, they formed that company, Ansys. Okay, so things can be seen in GitHub site. It is there. So they say QLEX has better performance than StackU, ProjectQ, Cycle, QSharp, QSkit Terra. Terra is another backend of IBM. QSkit Terra, QPy like that. it is due to that C or C++ backend, because we understand language like C and C++ can directly interact with hardware. But problem is again, I believe that this is basically for classical thing. Again, when you make it, I mean, port to this quantum, then maybe not that much good. Classical, maybe it is comparable with other, as they have mentioned. QLEX. Again, these two are from university. Another is StackU. StackU is a modern C++ 17 library. So it is again C++ based. It is for synthesis and transformation of image. Okay. It is basically a set of library. You design your circuit that can be synthesized properly. You can optimize it, right, for that purpose. Again, OpenQSM is again a quantum assembler. So circuit discipline is basically an assembler, quantum assembler. So that you can use, and sorry, that you can use. So normally, like C or C++, we use a header file. So here also you can use those header files to work with. Anyway, so BaseForce is another. So basically, it's a Linux framework. Okay. So it's again, since it is Linux, so it will be open source then definitely. So the machine learning purpose normally this is designed like TensorFlow, Python, all these things. Again, some other quantum software like D-Wave, Regated, IBM quantum that I will discuss, StackU, right? They can be worked with this possible. So again, this allow to create its own Jupyter notebook like Python. I mean, basically the Python Jupyter notebook you can use there, or some interface like R language or tables can be also used. Next is your BlueCat. BlueCat is again Python-based software framework. So it is designed for everyone. In fact. But here inside the thing is the CUDA. So it's NVIDIA's CUDA is actually the simulator, and above it there is again a virtual kind of thing. So that is BlueCat. This is CUDA base. Next, quantum programming studio. So this is again graphical interfaces because name is studio already. So it's a user to construct quantum algorithm and get the result directly using the browser, and you can run it in real quantum computers. Again, they are having no real quantum computers. You need to go for Google or IBM or so on. So that's why it is compatible with again IBM Qiskit, also Regated cloud service. Another is you can say QLEX. Right? So it is UK's Science and Technology Facilities Council in the center. And designed basically again for machine learning purpose. Right? So they claim they can simulate up to 38 qubits. Good if it can, but they can simulate only, not real hardware. Again, they also introduced noise model. Noise model is introduced basically to minimize the noise. Anyway, so they are having their own assembler, ASM, right? And Jupyter notebook can be used for that. Another is quantum user interface device. It's designed by Melbourne University. Melbourne University, I think they are designing it hardware, quantum hardware, a quantum computer they are designing, I think. So they have this programming simulation environment called QUI, quantum user interface. So it's very easy to use interface, user friendly. Drag and drop like your IBM Qiskit. Anyway, so it is, I mean, normally some servers are there. I think there is actual hardware there designed, and where you can again put your program there and get it back. Another is QLEX or QLEX, whatever you say. So it is you can run this over our normal browser, right? And you can simulate it, resimulate it, and you can get a result or any error or whatever occurred here. Up to 16-bit qubit you can work with this. Another is your QIBO or QBO. So it is and there is API provider known as Kilimanjaro. So it is part of that. So again, it is a Python. So you can run your everything quantum algorithm like that. Again, it supports IBM and other hardware. It is in a current, developing state. That's why alpha release is available. Next, another one is QUST. So again, it is a require a little bit higher hardware. So we have another processor like graphical processor, graphical memory. So we do there. So this kind of things are basically designed there too. That's their thing. So it is again C based, Python based, and multi-threaded and distributed system. Concept is used here. And so 1 and 2 qubit gets multi-qubit control gets possible, but the exact number is not shown. Anyway, so at least 2 qubit, 3 qubit also it will work. And with multi-qubit they have claims, up to 3 qubit at least. Extreme scale accelerator, programming model software framework, or workflow purpose normally. So a synthesis purpose, I think. So again, it's synthesis, so we can use the circuits, whatever synthesized result is there at circuit, you can work with IBM or Regated or whatever other. Another is Quantum plus plus. It's again C++ based because Quantum plus plus is C++ library. So again, they are claiming a typical Intel machine of 5 GB RAM. So they can simulate up to 25 qubits pure state and 12 qubit mixed state. Pure state mixed state, that is a different thing. We'll see later. So they claim it. But what we know or we understand in real practice, I think it is a little bit problem, but still, since it is simulation, so maybe their internal interpretation make it compact. So we don't know, no idea. Next is the quantum inspire. This is another again quantum platform for that. So normally quantum assembly language QSM is used for translating your configuration, whatever you design. There is an editor inbuilt, so you can use that editor. 32 qubit, sorry, 37 qubit, you can design a circuit that can handle 37 qubit. Anyway, so again, you can integrate with IBM also. Another is your QCAT, quantum circuit analyzer tool. Again, it's the Python based. So it has its own graphical user interface. So, so it has different modes basically. So can locally write program, you can see. Another is QUTIP. For dynamic and open quantum system, you can work. And this is, since it is a dynamic, the word we are coming, so it is related to mathematical kind of sort of thing. So we require NumPy for that. That's how all these things, all packages are required. So it is Python based ultimately. So anyway, So it has also one user-friendly interface, and all type of machine it will run. We have seen few of them only run on Linux like that. Almost all are actually running in all machines, Linux, Mac, or Windows. OpenQuantum that we already saw earlier. OpenQuantum basically for chemistry purpose. If you want to work with some chemical sort of things, then you can, because study of chemical structure also required high performance computer. That's right. Anyway, so again it is related to that we already have seen Regated like that. Another is TensorFlow quantum. Again, it is TensorFlow quantum to understand. It is related to machine learning, and it's provided by Google basically. So that's why StackU or CIRQ is actually compatible with this, because CIRQ is again Google thing. Next is Kuiper. What I find out of all this, Kuiper is a little bit complicated. Means you have suppose programming concept, programming knowledge. Directly you want to learn Kuiper, it will be a little bit difficult. So it is a scalable functional programming language for quantum computer based on quantum lambda calculus. Basically, this is designed on the basis of Haskell. Haskell is another language, functional programming language. So it's designed on that. So that's why we need to know a little bit of Haskell. Then it will be easier for us to go for Kuiper. Otherwise, directly it will be difficult for people to learn Kuiper. So like that. So normally Haskell was initially designed for physics application, so mathematics ultimately, but can be designed for other as well, no problem. So provides high-level circuit description language that includes gate-by-gate description, circuit fragments, that you can see in some tools, if possible tomorrow. So the Kuiper distribution libraries for content fixed point arithmetic, Fourier transformation, everything there. Next is QLEX quantum computing simulator. This is another one designed by QTech. So, low-level quantum assembly language, then quantum code that is there. So it allows the user to describe the circuits in a simple textual source code. Perhaps this is, let me see whether it is available here or not. It will be there. It will be like this, the QX. Right? Here, suppose we know Pauli gate is represented by X. So XQ0, basically we are putting Pauli gate in qubit 0. Time being, you can understand it is an where, suppose one quantum where is there. So on that where we are implementing X, this is Pauli gate. So Pauli gate basically will do what? It will Pauli X means it will flip the bit. Next, if you want to measure, so when we go for measure, we understand that qubit we want to measure, where we want to measure, because we will see the result in classical, we go for the classical thing. So we'll measure in Q1 and Q2. This will be a separate line for that. So Q0 will handle the qubit, Q1 and Q2 will be the separate extra line, NCDR, where we'll go for that, checking on that. Anyway, let me see some example I want to say. Okay. Quantum gates. These are actually the quantum gates admired, Pauli X, Pauli Y, Pauli Z. Right. So rotating gate, phase shift, C gate, C naught or Feynman gate, that is CX. So fully gate is there. All these gates. Many gate in fact. So let me see whether some examples. Yeah, here a headmark gate is put in qubit, first qubit, that is Q0. Now we measure that Q0. Right? So once you measure it, basically again we require some classical register. So D0 is a D0 is that. So now if again we apply polyget X gate to that. So once we apply this, we see what is the header D0 that is connected with the second qubit Q1. So like that we can do that. Similarly, if you want to measure all this Q0, Q1, Q2, we require thus three classical registers, so B0, B1, B2, that way. So these are few things we can see if you want, because it means why it's nice. Another is quantum algorithm, quantum algorithm too, basically. So it was Stephen Jordan who has actually categorized the algorithm and make it. So that's why name is quantum algorithm Joe, means lots of algorithm. Right? So it is also not, of course, for like the other we have studied. This is SCAP-CC, the scaffold programming language. So it's run on virtual machine, basically. Again, it's work on QSM, that is quantum assembly assembler. So you can basically see your algorithm. You can test your algorithm over here. So again, quantum algorithm means they compute and they work with the gates or the circuits. And there is StackU. This is another one. It's a backend compiler for, again, that we have seen for that SCAP-CC. With that, this can work. Next is QD Solve. It is from D-Wave. D-Wave is a very popular quantum computing company. So it is their product. Okay, so I think D-Wave having their hybrid, and they are trying to design a big hardware as per their comment, but officially I think that is not available. So they are trying to work with very big quantum computer as per their statement, but officially not released. So the processor currently limited to 1000 qubits per diamond. They are trying to move for 2000. They said this in 2017. But question is again the problem. Once you have this much qubit, means your memory requirement is very high. How this is handled? If they are doing this secretly, fine. So, but that information is not available. Quantum computing playground is another. GL this basically, and many Google engineers form this. So their work can work up to 22 qubits. The GPU accelerated gate level quantum computing with some sort of ID interface. It's known language for debugging, again for 3D state visualization, like BOSH fair you have seen like that. Next is quantum in cloud. This is another. It's again designed by University of Bristol. So 4 qubit photonic quantum computer. Again, this is related to light. So the optics basically. So they try to problem specific, because reversible things are normally problem specific. That is the reason people are designing problem specific computer. But we require general purpose computer, not problem specific computer. Anyway, their own choice. Another is Raytheon Debian open source software. So they normally related to QLab. It's like a MATLAB control framework, but it's for qubit. MATLAB is for our classical bit. QLab is the Pi simulator. Is there? It is a Python C++ framework for equation simulation of qubit system. Next, SpiQ lab. All right. So it is a framework for superconducting qubit system. Sometimes you get language QCL. The QCL I have not mentioned, but there is a language called quantum gate language. It's there available. You can see, and there are lots of more. Perhaps you are exhausted. I am also exhausted. So many such languages are available. So this part I will stop here. Next, we'll try to see the language. First, let us see how briefly we'll see how. Let me see what I have. Okay, I will try first. Just briefly, I will mention CRQ, Google CRQ. Then I will try something else. Let me see. So again, that CRQ already mentioned, but let us see little bit of internet things.
So probably there is a query in the chat box. If you can see in the chat box.
Okay. Okay, someone asked this question. Someone asked this question, which one is user friendly for working with QML for beginners, as you have worked with different tools. I'm sorry to say I'm not working with different tools. I'm working with a few tools only. So that's why I just directly can't say this is best, or because I have not used all the tools. Since I'm little bit interested on this, so I have seen this, so I know little bit about them, but I know few tools. I have used only few tools. So, but since you are asking which one is good for that, I personally think Alibaba you can use. So you need to register there. So it may be good for that. I mean, for machine learning purpose. Other also they are available in the slides. It's there. There's a net also. But what I say, Alibaba may be a little bit better for that cloud service they have. So you can see that. But again, I'm telling you, I'm not using all the tools. Though I'm telling all these things. So simply I'm trying to bring this thing to your attention so that you can see that so many things are there. Right? There's quantum. We heard that word, but many things people are doing. So just I want to bring those things to your attention. Anyway, next is okay. So this we have seen earlier. So again, it is a Google base. Still that not official part of Google, but to see it is a Google base. All right. So again, it is open source that we know. So you can use for writing, manipulating, optimizing a quantum circuit, but not a very big kind of things, big circuit. This up to I think 52 qubit level, you can do that. And again, they are dealing with what the noise, because noise normally appears in quantum computer. That's why. So, it's a good one because we'll put lots of research on that. So how will you install this in your Linux system or this? Is very easy. Most of us understand how to do. Simply use your pip, install CRQ, so it will automatically do that. Or you can upgrade it also. If you want upgrade means you can use this also. you need to preload it, you can use it, and that you know that is available also. For Windows also same command, no problem. For Mac also same command, no problem. Or you can write a small script like this also. Try import StackU, except import. I mean, if it's not installing or like that, so you can use this command also. It's possible, you can do that. Now, whatever qubit you understand, that is okay, fine. This is your all mathematical, theoretical, whatever. But here in StackU, they handle it in three different ways. One is your used to label qubit by a name, particular name. Another is label by number, is in a linear way, array kind. Another is labeled by two numbers. So we can think this to be a rectangular lattice, two numbers. All right. So the first one labeled by any name, so that is that's my name, named qubit. If you see, it is a named qubit. It is named qubit. If you see, that's named qubit. This is very important. You need to know that. And if it is a linear way, if you want to do array kind of thing, then it is a line qubit. So that there is a differentiation. And if you may want to create a lattice or grid kind of thing, so it will be grid qubit. Right? So like that. Next, one small example just I want to see here. So, if possible, we'll see more. Maybe in the real environment, we'll try to do that. But today, at least, we will not do that. So here, first you need to import like Python. Import that package you installed already. All right. Also, you import share to Google that path. Many issues are related to that. You need to do that. Then you have defined two variables in language term, and for us they are qubit, Q0 and Q1. And suppose their name qubit, so some name you have given Q0, any name. So name qubit purpose it will be there. So one is suppose Q0 is a source qubit. And if we say this to line, this will be your Q0, this will be your Q1 suppose. So this is a source and this is a target. So line qubits can be created individually if you want. If you want, suppose Q3, another. If Q2 is not there, suppose Q3. Line qubit. You can do it. One. So here total 3, 0, 1, 2. That way, Q0, Q1, Q2 will be created. Q0, Q1, Q2 will be created. If we write line qubit, array kind of thing. Anyway, similar way, in a range you can do this if you want. Suppose Q0, Q1, Q2. All right, you want to create. This is if you see, this is a Python syntax basically. And the three variable you can make it in the line qubit. All right. So grid qubit can also be performed individually if you want. 4, 5 meaning is if you create a grid of suppose something like this. If we say 0, 1, 2, 0, 1 is there. So then, apart individual, qubit if you want to target, then it may say 2, 1. 2, 1 in this latest 2, 1 is this position. So that is displayed there. Or in a big way, if you want, you can put a range 0, 0 to 6 like that. It is total 16, I think. You can do that way. Next, what are the features in StackU? One is circuit, and there is device, and many more. The circuit, you can build quantum circuit, and you can optimize if you want using the algorithm or your own algorithm. The next is device, how you handle the different constraints and program Google's quantum computing services. That is the quantum hardware and the simulator. That is related to the device. Under there is simulation. The built-in simulator are there for wave function or density matrix kind of thing. And for quantum noisy quantum channel, Monte Carlo, full density matrix simulation possible. Yeah, QSIM is also possible, and in fact, government of India is working on quantum simulation, that is QSIM, based on QSIM. bigger circuit that is. Supports two types of simulation. One is pure state, I told you, and there is mixed state. Pure state, you have to use this particular command, crq.simulator. This is for pure state. And for mixed state, it will be density matrix simulator. So these two you need to work. Means what you, depending on your need, you will use any one of them. Suppose pure state simulation. So if you see here, we are importing that circuit and we are creating two grid qubit. If you see 0 0 1 at 0 0, another 1 0. So then we are basically writing a function, basic circuit, right? So here measurement is true, suppose we are telling. So what we are doing, square root x equal to, it is actually, we can say like this, it's like this. Anyway, and it will yield after doing this, square root is basically the name. What? Again, x q0 and q0 and q1. Similarly, we are using control Z here. So means we are basically if you have two lines, so not line q0, so we are using cz over here. There is. So now if it is measurement is true, then we will do what? We will measure it if it is true. Already it's written here true. But then you call the circuit function, and if you want, you can do what? Sorry, once you call circuit function, there is already one circuit available. Means a structure is there. So that's why whatever you have designed, your design is basic circuit, right? That you have designed. That must be appended. So we append it. Now you can print the circuit. Once you print this circuit particularly, you see your result will be like this. And because it's a grid one, so 0 0 and 1 0, that is the name you have given. You see it is 0 0 and 1 0, the name you have given. So and here x, and that is square root x. So these two operations are given, and this is your control connection that is there, and this is the measurement value. So you are measuring, if it is true, you are measuring this 0 to 1. Right? So this you need to remember basically. Measure the function measure, what will be the arguments. Right? But once you are familiar with Python, it will be easier for you, and you can easily do that. So our output is not very, what to say, interesting, but still it's okay. We at least understand. It's representing a grid. So 0 to 1 means 2 cubing basically, and we are performing some square root operation over here. Next one is your what is this? Using a run method. Okay, so you can use the run also. If you see here, it's a run method. So again, here we'll import simulator. Now you are using simulator over here. It is pure state simulator. The simulator function that is your created, instance is created for this, and you try to use the run method. And the circuit already you have created because we have appended. No, here we have appended. In the circuit we have appended basic circuit, the new circuit. So that will run. Once you run, print the result. Once you do that, you will find the qubit. This contains 0 and Q1 contains 1. But problem is using that the pure state actually cannot access the state depth. Sorry, not pure state, this particular one cannot access the state depth. Right? You can see only here the value of in the form of bit. In the case of qubit, we are seeing the value as 0, 1, whatever available. All right. So if you want to access state vector, because sometimes that is also important in case of quantum computation, you have to use this thing, simulate sweep, right? And that moment state also, if you want that, so that can be used. So for that, let us say, since it is a vector again, state vector, so we require numbers. So then we'll again call that basically constructor. So circuit Then we, with basic circuit, initially false means there is no circuit, you can say. There is appended, so it is a blank structure. All right. Then we call the simulator. So that circuit we have created to do that. And our qubit is ordered as Q0, Q1. Order meaning is basically their appearance. Q0 and Q1 appearing first and second like that. So that order. By default, also order is same, but always we give the order. Then we do what? We see the result. So result of final state vector. So these are actually, you need to remember all these things. All right. So 3 state vector that we want to see. So your result will be like this: 0.5, 50% probability, and 0, here 50% probability. So here both the 0 and 1 here 50% and 50% probability. All right. So like that. So state vector can be again seen using this. Using RAM, you can't do this, but using this simulator and simulate. And if you want to debug, then the simulate sweep is there. Perhaps I told you. Simulate sweep is there for debugging, and moment also there. What is moment and other thing that I'll show you later. Right now, that may be a new thing to you. Next, qubit and empty should ordering. That is one aspect, means where things will be in row order, row measure order basically. So if you consider an array, suppose 0, 0, 0, 1, 1, 0, 1, 1, that is a row measure order, we say. So normally they are in this order, qubits. That's why that ordering is important. Sometimes change of ordering actually a change in the outcome. So how you want to put them, that is. But by default, it is a row measure ordering. So the ordering with a circuit that flips one qubit out of 2 can be checked. If you want sometime, so that can be done. So here suppose one name qubit, all right. Name is suppose this one. Name key, another one is this flip, another is Q state. But now we'll see say Q and flip that on X we are looking into, right? X we understand X gate, admart gate, that you perhaps you know. I hope you know. If you don't know, again I need to explain them. X and admart. Anyway, so you want to flip. So then first qubit in order flip. In order flip means disorder, row measure order. You can make it. We'll use that again. Simulator, simulate, right? So C is basically that circuit where you apply the X. So that again order will be what? The flip and stay means just opposite, because you are flipping it, and absolute zero taking. So again the final state vector, and all these 3 must be rounded, right? This time it will be in the rounded outcome. Second qubit order flip, for that purpose if you see, it is Q stay and Q flip. Earlier it was Q flip and Q stay, so like that. So these are different way to do so. Then simulate moment state is also there. If you want, you can do that. Debugging various state in the system, that is possible. Modifying is possible. Right? What is the state if you want to pin? If check, that can be done. Again, circuit is called. You append basic circuit. Right? You are appending with the basic circuit. So if you see, this is simulator simulate moment state. Again, one we have seen here. We have seen one thing, final state vector. This is one, and here if you see the same simulate moment state. These are variable. Sorry, they are function related to your simulator. So that if you want to see all the steps will be like this. Step 0, what is the step vector? 1, 2, what are the steps? In all 4 steps, you will get the value of step vector. And basically, what is this? If someone asks, what is this? What is the meaning of this? Normally, sometimes we run our code repeatedly in the sense so that we, if you run the program repeatedly in case of quantum, there is a possibility you will get the result, the best result out of that. So that is the motto. So here we'll get that way, and out of this maybe one will be the best result, right? The reason is it's depend on the superposition of the bit. Again, what is the superposition? Basically, when suppose 0 and 1 is there in a globe, one side 0 is written, another side 1 is written. If you what to say, you sweep the ball, all right, then what will happen? It will be difficult for you to see the 0 or 1. Sometimes as if you are seeing 0, sometimes 1 like that. It is basically kind of superposition. So basically that. Anyway, that is a different aspect. So, okay, mixed state simulation, earlier is pure state. Mixed state will be, you can combine both, all right? So that is mixed state. So here you have a main qubit, Q is the name, and Hadamard gate is used in the Q, and again amplitude damping is there, that you use that and the amount you have to write will, and you have to measure the Q. The whole you need to pass to the circuit, because circuit is a constructor function that we have seen. Circuit is a constructor function. That's why sometimes it will come without comment before constructor, and now it is with comment. So then we'll call this the simulator density, because it is your mixed state. So density matrix simulation, and we run how many times? Say 100 times repetition. All right. So again, you want to see this in histogram, and p value is suppose a, because we have named this as a. So if you want to see this 100, so histogram 100 times, if you run, what will be the value? What is the value that we want to see? All right. So out of this, what someone will be more accurate. Right. And then the noise again, I told you like that. So create a state in equal superposition of 0 and 1, and apply amplitude damping, which takes 1 to 0 with some like a probability of 0.2, that is amplitude damping. Next, what it can be noticed that instead of 50% of timing being 0 about 0 in 0 state, or 20% will be in the 1 state. So then converted to 0, so total around 60% in 0 state. Okay. Anyway, so like the pure state simulation, the mixed state simulation support run and sweep both. Run sweep. Some information are here, you can see this. So this is for result. If you want to see the state vectors, we see 0 possibility of 0, 60% of higher, and possibility of this is basically 1 is 40%, 44% almost, and like this for second one it is like that, right? So these documentation are from basically quantum AI. It is from Google, taken from that. So you can look into that. So they are almost same from that I have taken this. So you can see from that. Next, we want to start today one language. But before that, I think, of course, that language you can start, but since the things are continuously going on, we can see one small thing over here. If possible, let me see this. So, when we are discussing about quantum, there is one trivia or a theorem, you can say. The Schrodinger cat. That is, suppose there is a box. Inside that box, there is a cat. Now, if you put a bomb over there, means lots of interpretation of this problem is there. This Schrodinger was an Irish person, so he initially introduced this thing. So he hates the cat. So when you put a cat box, whether that cat will be alive or dead, of course, when bomb will explode, it will be dead, or may not be dead. So when it will be alive or dead, it will be difficult. Can you say So there is a probability 50% chance that that will dead or alive. So basically death. So it's related to the quantum mechanics. Also, it's related to entanglement, teleportation, everything. So let us see a very small video on this, if possible. Try to stop. Small video, just understanding the quantum sort of things. Um, just wait. Okay, so that was a short video on the Schrodinger cat example. Anyway, so we can see this video if you want. It is quite interesting, though things are animated form, but things are interesting if you look into that. You'll see it was really I mean, interactive one, and you can understand the concept at least in a very brief way. We want to start today a language because I told you there are lots of softwares or software development kit or languages for quantum programming, but again it is difficult for us to handle all one. So we'll try to do what? We'll learn today a language that may help us to learn the actual quantum language, because the problem is if we directly go to that actual quantum language, Kuiper, it will be difficult. It's a little bit difficult for learner or beginner. So you need, that's why you need to have some idea about another language, because Kuiper is based on this language. So let us see that language, how this language is, or what this language is. So we try to see a language known as Haskell. Anyway, let us see what is this. So again, it is a functional programming language. So you require a compiler to run this is GHCI, the compiler you required. So this it's like other functional programming language like C, you know. It is, we say it's a lazy sort of thing. Why lazy? Because it won't evaluate an expression without revision. There must be a reason to do so. That's right. Then when the evaluation engine finds that expression needs to be done, it's a little bit intelligent actually, though it is lazy. Then it creates a thunk data structure. Name is thunk. Collect all the required information for the specific evaluation, whatever you are doing, and a pointer to that thunk structure will be given. So the evaluation engine will start working only when the required evaluation expression is done. Next, it has the modularity. So Haskell application is nothing but a series of functions. You can say that the Haskell application is a collection of numerous small Haskell applications. It is statically typed because they are typing. Typing is basically when you name a variable, like integer a, float a, that is the typing. So it is statically typed, but fixed one. The conventional programming language, we need to define a series of variables along with the type. In contrast, Haskell is strictly typed language. Right. So like those, it's old days, not nowadays. Old days, people used to use quick basic. So quick basic language, if you write a equal to 10, you understand a is actually what? Integer type. Next time I may write b equal to 20.5. So we understand b is a real type. Real type. So, but that I have not defined this. In C, we normally put integer a. right, or float B like that. So these are strongly typed languages, and these are loosely typed, right, because the type is not defined. So some languages having this. So loosely typed languages are not that much good. So, lots of drawbacks, but for they are user friendly. Easy, you need not worry about the type. These are statically typed, so you have to give, right, the actual typing. Maintainability is there, so easy to handle it. So it is for multi-threading purpose. So synchronization problem can be written. It's good for that. So it has a different types of three different types of installer basically available. One is a minimal, another stack, and the Haskell platform. So for that, the Glasgow Haskell compiler CI, that is name is GHCI. So that is cable is used, right, for that. So if you try to install, you will see that options what you want. Minimal installer, stack installer, Haskell, and number of bit in your computer is what bit of computer your computer is, 62 bit, 32 bit, what. So that, depending on that, you install it. Next, for stack base, it is stack installer. It is a cross platform basically. Lots of API tools are here. Next, Haskell platform. It is best actually, so you can use this one. Anyone, but this will be best idea. Now let us basic data model. So what are there? Say their numbers. So Haskell can decode a number the user normally gives. So you need not to mention type externally. Now if I write example prelude, but they are internally, they're strongly typed, but they're internally, not externally. Internally strongly typed. Prelude is basically it's command line. You can say command line means when you open up in command line, you'll see that prelude. And there, suppose you have been 3 plus 4, so result will be 7 like that. So prelude is basically the command line. So for character purpose, you have to write colon T. T is the type. You have to write this. For number, it is not required. Number also you can write if you want. It doesn't matter. So Z letter is written. The output will be like this. G is a character. Alright, part of character. Key for type. Next, suppose ASCII and string. So if we write in the command prompt, prelude, quotes underscore 65. So this is ASCII equivalent of capital A. So capital A will be. Suppose I am writing a string, Assam is in college. So I am writing the T colon T. T is for typing. It understand whatever written there that type. So it is a string type. So output will be Assam is in college character, but in bracket, meaning is array of character. So it is a string. So that output will come. So again, for Boolean purpose, we write true and true, result will be true like that, true or false like that. So Boolean also data model is also there. Next is list, like your Python list is there. So these lists are normally homogeneous and they are mutable. Mutable means you can two types. One is mutable, another is unmutable. So whether modification is possible or not, like that. So modification possible, so not mutable, modification not possible, non-mutable like that. Anyway, suppose in that command prompt, prelude is the command prompt. So we'll writing 1, 2, 3, 4, 5 is the list, because in Python also we'll write same way. Output will be like this. Say maybe your A, B, C, D another list. So this is our input and our list is used. Another is list comprehension. So it is basically mathematical expression you can use here. Syntax is like this: output, pipe, range, comma, condition. Suppose here I have written X. All right, it's a pipe, and I have written like this: X, pipe, X. You have to write this direction. 1. This is the range. All right, and right. Once you write this, This X will be replaced by 1 to 6. So it will be a list like this. So it is list comprehension. Sometimes also you can use mathematical expression like this. Suppose here it is written like this. X is multiplied by 2, 5. Direction. This is 1, 2, 6. So once you write this, 1 to 6, whatever there in the red, it will be multiplied by 2, because that definition is given over here. This is the output. So initially it will be a little bit clumsy, but once you work with it, it becomes easier. The tuple is a similar way available in Python. So it is immutable data type again, right? A heterogeneous, list homogeneous, same type, and tuple you can mix. So you see number and character are there, like this. Also, there is a difference in the packing. This normally in the square bracket, tuples normally if you see they are in parentheses. Next is some basic operator. If you want to see, say addition operator, how it will work. Here we need to write. It is a structure of the Haskell program. You have to write word main, then equal to do. You have to start with this. Then these are coming as capital. It is not capital. They are small actually. Main do. Next we'll write relate some variable, some any variable. Let us say a b equal to 10 or 20, whatever. Next let let's say be equal to 40. Next for output we have various commands. One is puts string line strlen. Suppose some message you can give over here, some message. Next, suppose the result I will print directly. Print is another output function. So what AB plus B. So this is your addition operator. So result of 60 will be there. So these are basically for output purpose. So put strlen basically print the string, right? But if you want to do this addition result, you just can't put over in strlen. You have to use print for that. Right? You print that. Print can also print other thing also, but puts strlen only can in the string. This is similar way you can go for subtraction, multiplication, division, so on. Suppose there is another sequence of range operator that we already know. Suppose again main equal to do, that you have to write. Print range is given in bracket square bracket 1, 4. Meaning is 1 to 4. So if you print like this, 1 to 4 you print. So range operator is there. Next decision making if else nested if all are available, like the other language. Inbuilt type and type class. So I told you already, colon T basically for type, right? For mathematical purpose normally they are used. And here integer int, not integer, int is a type class. But int is a type class. And it has a range of this much. You see, it's a very big number. Right? 214 crore almost. 214 crore, like that. That much long. And up to negative that much. Almost that much. Like that. So that is the range of your int. So now let us say we want to write a small function over here. It's basically a function. What is written in the function? If you notice f type, it's a name. You can give any kind of name. I'm writing some f type. Any name you can write. It's a function name you are giving. These are different. Here we are writing suppose int direction symbol int direction symbol int. Meaning is this f type function basically takes two arguments, integer type arguments, and return one argument, integer type. So basically that is the thing. So it's written that way. Next f type, what we are doing, we are giving passing two things over here, x and y. And what is there? First x will be again multiplied by itself, and first number, and second number is multiplied by itself. That is it. And they are added. Okay, then we are calling, I'm calling this inside main. Main equal to suppose print. Directly I'm calling main print. What? Function name is f type. Suppose we are passing two numbers, 4 and 6. So what will be the outcome? Because f type is the function name. Arguments are 4 and 6. It will be 4 and 6. It is 4, 4, 16, and 6 is 36. So result will be 50. Alright. So here does you can call a function and you can use int. But if you give a bigger number, alright, suppose bigger number, it is 10, 5 I'm writing. Instead of 10, 5 or 4, 6 I'm writing. If you give a very big number greater than this, there will be an error. It will show some error. So some number bigger than this, 214 crores, bigger than this number, it will give an error. Next is difference between int and integer. Already you have used int, right? Now another is integer. Integer is another term here. So integer can be considered as a superset of int, a value not bounded by any number. Previously it was bounded by some number. So sometimes we require to bound the things. That's why you can use int. And if you don't want to bound that, then you can use integer. So here, again, the same function if you utilize f type, right? F type is any name. You don't worry that you have to write f type, any name. Next, you see scope resolution operator is the integer forward direction. Integer forward direction means again the same thing. Two integer argument we pass to this function f type, and this function will return another integer. That's why it is 3. So what is the operation? This is the function definition. Same thing. We the first number will be multiplied by itself, second also multiplied and then added, and result is given. Now if you see, after suppose I am printing this number is little bit big this time, so it will very easily it will add the number and it will print. All right. So like this. So similar way, you have float, you have double, you have boolean. All these data model types are available. Suppose character type, if you want to see, it will happen here. So again, f type is a function name. F type is a function name, suppose. It is like it will take one character and return one character. Right? So suppose we are assigning a character to a variable x, that is k, capital K. Next, we are doing what? Calling this function. Again, I'm on local variable I have decided x equal to v, small v. Now I'm printing f type x. And f type is your that function x. Now, normally what we think that value of v will be printed. Will not. Yeah, value of k will be printed. Alright. So it will normally stick to that value. So that passing by reference mechanism is actually not required here. Passing by reference is required in C and C++, but not here. It can handle that. Next is EQ type class. That is basically for checking the equality or so on. So here, if we see, if we write this, this is not capital, small main do. If 9, meaning we are basically doing what? 9 equal to 9 by 9. We are doing this. So then what? They are equal. Else they are not equal. So of course, since we do this, they are not equal, 9 equal to 1. Result will be not equal. So this particular is actually part of EQ class. Yeah, this is the operator or value. Anyway, so EQ class. And next, there is another round is odd. Odd is another interface class which is functions of ordering. So these things. greater than, smaller than, greater, equal, greater, or compare. All things here. Compare is also part of that. Like this, main print C is greater than C, so result will be like this. These are part of ORD. So another is show. But that plus next show. So what, like print actually. Normally you can print it. Print is there definitely, but if you write show 1 to 6 the range, it will output will be like this. All right. Basically, show will expand this, similar to print. You can write this print 1 is to 6, still will work. Next is read is another. So like show put the pin value is required from a like this. Say main program will start like this, small m, remember. Print, suppose a variable is given, right, and number is 34. This is a variable. Read int is a variable. So read int string integer, right? Because though it is your 34 is number, but it is written in code double question is a string. So we are converting this to string. Again, what we are doing, in this variable we are writing this read, meaning it will now be taken as integer. The value will be 34, not string. If you don't write this, result will be 34 as string. So that's this possible. You can use read for that. Similarly, there is an enumeration kind of thing. So here, what you can do, another type class. Here, these things can be used. This command succ, pred, boolean, etc. For example, if I write main equal print pred 34, output will be no, sorry, not 32. I'm sorry. Will be predecessor of 34 will be 33. So result is 30. If I write SUCC over here and print SUCC 34, it will be 35. Like that. So you can use that way. Boolean will return true, false, that. Anyway. Next, you have a bounded kind of thing. So here you can check the bound. So int, what is the bound? This bound can be set like that. Or you can fix your own bound, and the next bound is basically part of the similar. You will get min bound or so on. Now there is another custom type class. So it is user defined type. You can write your own. So there is a data area. Basically, the area is the name of the. So 3 float you have seen circle, float, float, float. All right. Meaning is 3 float variable can be considered. And outcome will also be the float one. Okay. Now what we'll do, we'll use surface. Surface is basically again another name of the area. So basically this is also a function name. Now area is a function name. Surface is also a function name. User defined. You have given. What will be area point of float? Meaning is whatever area is there, it will result in the float. Meaning is that. The surface circle R. Circle is your this name. You provide that. And R will keep your user input. All right. Here I directly calculated 3.14 all decimal value and R square. I will, if you print now this, so we will give surface, the name of the function, and the circle. It is also acting like a function now. 10, 20, and 10. These are basically 4 types, but we have given as a desired type. So now what happened? It's like area become a new type, right? User defined data type. It's become user defined data type. And data is your reserved keyword you have to use. You have to use data that is part of that. Now area is user defined data type. It is basically a function but acting now as a user defined data type. Surface is again user defined. Basically function and intermingling between two functions like that. Similarly, if we want to add, suppose function, how function already you have seen. Let us say add is a function. It's user defined. You can write any name, whatever you want, as add. So again, meaning is what? It will take two integer and return one integer. So this is the definition of the function x plus x added, and result will be like this. This you need to write two variables, so two variable multiplication. So main do. So what is that? Add is the function. 10 and 14 will be added, so result will be 24. If you write this statement, result is this. Functions are passed this way. Next is the pattern. So it is like recursion kind of thing. So here fact is a function name user defined you have given, and it is like it will take one integer and return one integer. And what is written here, you see it is a little bit typical. Fact 0 equal to 1. We'll see what is this. Meaning is it will toggle between 0 and 1. In fact, we know it is a part of recursion, right? So n minus 1, so whatever value of n is, so I have given suppose fact 6. 6 will be decremented one by one. And what is done? So n is 6, suppose this is 6. This value will n minus 1 is 5. Meaning this is 6 into fact of 5. Again, fact of 5 meaning is what? It will be, because this is the function, whole function, n will be replaced by 5 and fact of 4. Again, it will be what? This fact will be 4 into fact of 3, n, because n minus 1. Again, for the next, it will be 3 into fact of 2. It will continue because you have put a condition over here, right? It toggle between 0 and 1, whatever reach earlier. Next fact 2 is coming like this. Next one will be what? 2 into fact of 2 minus 1 is 1. Alright? So it is still like this. Next, 1 into fact of 1 minus 1 is 0. Fact of 0 means it will return 1. It is 1. Now this will return 2 into 1, so 2. So this will return 2. 3 into 2, 6. So this function will return 6. 4 into 6. This function will return this. So 5 into 24, this function will return that much. 120. Next 6 into 120, so this function will return that. So like that. What is that? 6 into this. So result will be 7 into like that. Alright. So here the compilers start searching for function called fact. Fact is the function name. This way we write, and it's an argument. So argument is not equal to 0, then the number will keep calling. The same sum with 1 less than this, and what I've explained over here like that way. And once it becomes 0, value will be 1. So it will produce the value and you get the result. Another is similar kind, guard. Guard is another thing similar to the pattern matching. Basically, here pattern is this one, 0, 1, whatever. This is the pattern. Once you get the pattern, here you see, you can write. Again, fact is a function name, and it will take one integer and return an integer. Here we have writing fact n, the value of n. What is the guard? N should be, once it is equal to 0, then we assign 1. And next case, again we are putting a pipe. We are dividing that n, alright. What we are dividing? We don't think this is 0, this value, right? Whatever that fact will return. So this way we will continue. So 0 is put because sometimes we may get n is 0. So in main, if you do again the similar, calling is similar, so you can do that. Use guard. Next is what? Higher order function. So higher order function, okay, you can use a function as input or output argument. So that is possible. Say import data, the character data input. So that input data the character. So import prelude hiding map. Right? So meaning we are now hiding that prelude. We are not using that prelude kind of prompt. We are not using. So map is actually user-defined, not user-defined function. It is part of your Haskell. Other what fact or other feature, everything they are user-defined, but map is not user-defined. All right. So here we are mapping within two. Here it is though it has a positional variable. Particularly, we use them for declaring array time. But here it is not array, maybe string or so on like that. So now map is inbuilt function. So now what we are doing, map FUNC. So FUNC is our user defined function. All right. So we are writing ABC to this variable X, and that we are again assigning to this. Now we are printing. So you see, print $map to upper, suppose this number, this string. All right. To upper is an inbuilt function. To upper is an inbuilt function in the data character because that we are using. So if you write this, what will happen? It is in GUIST. Right? So you see, map is basically inbuilt function. To upper is also library function. Right? Print, we understand this is also another kind of function for printing some result. Right? But here specialties we have to use that dollar in this case, and it is a string. You need not to write any something in parentheses or like that. So initially these are a little bit complicated, but later on once you do, it becomes easier. Right. Similar way, sometimes we can use something no naming, all right? Simple kind of things, so lambda expression or lambda function. Basically going to be used only once throughout the entire application. Lambda function normally limited by this slash character. We need not to function without having a definition is called lambda function. Suppose here if see we are writing the program main do, that is the right, the successor of 6, this is statement only. What we are writing, you see, this is a lambda thing. What we are writing, x, what x is pointing, x plus 1, meaning is this value will be x plus 1. So what we are supplying, 6, so meaning is 7. So it will print 7. All right. So it's like that. So does this is acting as a function. For complicated one, we cannot write this because multiple statement may be there. Then of course it will be difficult for us. Similar way, we have few things: head, tail, and last function. Suppose we have a list 2 to 6. If we write print head list, then 2 will be printed. If we write print tail list, then 2 is basically 2, 3, 4, 5, 6. This is the list. If we write head, then 2 will be printed. If we write tail, then 3, 4, 5, 6 will be printed. If we write last, then 6 will be printed. All right. So now you see they are also function, because you see normally what we write here a function and whatever variable, whatever the data model. There is a list over here. So this is your function, this is the data model or whatever the variable, whatever you want. This is a function, this is a function. This is print also function. Normally we used to write this way. There are some. Sorry, this is not reverse. It is reverse. The reverse function, null function, lots of things are there. other function, that is a len function is there. Next, another is take function for creating substring. If you see, print take is a function. 3 I'm writing, 1 to 6. I'm putting 1 to 6. 11 3. So 1, 2, 3. Total 3. So 1, 2, 3. This will be output. And there is drop function. So here you see drop 2 if you write. So first 2 will be dropped. 1 and 2 will be dropped. And rest will be there. Like that. So there's lots of, possible. The maximum thing, if you want to see, you can see sum you can use. Just sum whatever list you provide. Product also there, you can find product of whatever list or whatever 2 numbers you provide, like that. So this way. So many things are there. So I think today we want to stop. Tomorrow we'll continue from here, and then we'll see tools, if possible. This tool we'll see, or maybe other tool, because we require interactive tool. This tool is not interactive, so interactive tool will be better. So we'll see. So for today, I want to stop here. No, sir, I want to stop here today.
Thank you, sir. Hello. Thank you, sir.
Yes, thank you. Yes.
Hope our esteemed participants have learned a lot from you, sir.
Hopefully so.
Hope to meet you again tomorrow, as tomorrow we have another session with you, sir.
Okay, fine.
Thank you once again, sir.